Good morning, good evening, everyone. Welcome to the series of webinars organized by the Computational Social Science Laboratory, Faculty of Social Science, the Chinese University of Hong Kong. I'm Bo Huang, a co-director of this lab. I'm very pleased to chair this webinar. Today, we are very honored to have Esteban Mauro with us to give a webinar on inequality and epidemics in cities at a higher resolution. I didn't know him as we are in different areas until I came across his article published in Nature Communication titled "Mobility Patterns are associated with experience income segregation in large US cities." I thought the idea is quite interesting and novel. Then I took the liberty of inviting him to give a webinar, and he happily accepted the invitation. That's why he is here now. Dr. Esteban Mauro is a physicist by training. He is currently a visiting professor at the MIT Media Lab and also a professor at the University Carlos III or UC3M in Spain. Esteban's work lies in the intersection of big data and computational social science, with a special attention to human dynamics, collective intelligence, social networks, and urban mobility in problems like viral marketing, natural disaster management, or economic segregation in cities. He has received numerous awards for his research, including the Shared University Award from IBM in 2007 for his research in modeling viral marketing in social networks, and the Excellence in Research Awards in 2013 and 2015 from UC3M. Remarkably, his work has appeared in those top journals, including Nature, PNAS, and Science Advances, and is regularly covered by media outlets such as The Atlantic, The Washington Post, The Wall Street Journal, etc. All right, without further ado, let's welcome Professor Mauro. Professor Mauro, please.
Thank you very much. So I'm going to share my screen. And this is the critical moment in which hopefully everything works. And I hope you can see my screen and you can hear me now.
Yes.
Well, yeah. Well, thank you. Can you still hear me?
Yes.
Okay. Well, first of all, thank you very much, Professor Tonitana and Juan for inviting me. It's a pleasure to be here in this computational social science seminar at the Chinese University in Hong Kong. Thank you very much for all of us, all of you to be here. And it's an honor to present our research in this venue. So I'm going to talk today about something that we have been doing for the last 3 years. This is a project that started at the Media Lab, at the MIT Media Lab. For those of you that let me remind you that the Media Lab is a special lab within the MIT. It's a lab in which we basically a number of people for very different disciplines work together in specific projects. So we are not a department per se. And we have a group which is called the Human Dynamics Group, in which the director of the group is Sandy Pentland. You probably know him. He's one of the proponents, he's one of the main researchers in the area of computational social science, and this project has been done within that group. Obviously, this project is not I'm just responsible for communicating the results of the project, but this project has been done with many different people, and what I'm going to present today has been done in collaboration with many universities, but also with a lot of companies and sponsors that have provided us the financial and the data support for this project. I want to mention my students in Universidad Carlos III, but also collaborators in Oxford University. I also have a collaborator that I'll be working with in PolyU that was visiting us a long time ago, and also the people in Northeastern University, in Universidad Zaragoza and the Queen University in Belfast. So you can see this project has been done with a very number of different people. And the reason why there's so many people from many different places is because this is a very interdisciplinary project that requires people coming from social sciences, from public health, but also from computational social science, networks, and even engineering. Okay, so the basic idea of our group and our research is that we have, all of us, we have this amazing sensor that is in our pocket that can allow us to detect not only what applications we are using and I mean who we talk to, etc., but also can inform us about the mobility. I mean how we move around in the city. Probably most of you know that there's a huge market out there of companies which are basically aggregating this data, this mobility data, and in an aggregated and a private way, they share this data for commercial purposes, for marketing especially, but also in the last years, there has been a number of companies that have shared this data to researchers, for example, us, in order to understand a little bit more about our societies. It's important to know that the location data, this mobility data, where we are and how we move around the city, comes in, the first one is the CDRs. Basically, this is the old traditional data that comes from mobile phones. When you are making a call, the mobile phone has to connect to an antenna. It's basically a tower in which you connect to that antenna, and the telecom company redirects your call through the antenna to the rest of the, let's say, the network. Obviously for network purposes, this event is recorded, and then you know where this person, with which antenna this call is registered to, and by using this antenna as a proxy for your location, you can detect where people are. Typical resolution of the antennas within cities is about 100 meters, but in rural areas or in areas which are less dense in population, this resolution is about 1 kilometer. And since people usually talk or call every hour or every 2 hours or even half an hour, the typical temporal resolution of the CDRs is 30 minutes. So you can see that there's a lot of things that you can do with this data. It's very cheap actually to collect this data, and this is how traditionally telco companies has been using CDRs and XDRs to inform mobility. This data has been used, for example, during the COVID pandemic, to track movements of people between regions, between provinces. Like, for example, people going from Guangzhou to Beijing, or from from Boston to New York. It's very, very accurate, and since most of us are connecting to an antenna for data purposes or for calls, you can actually have almost 100% of the let's say of the users, of the phone users, of the phone clients registering these areas. The other technology, which is the one that I'm going to talk today about, is the GPS and what is called the location-based services. This data comes from the apps. So think about the weather application that you have in your mobile phone. Every time the weather application gives you a prediction or just the weather, how the weather is like, it uses your location to give you a more precise, let's say, weather prediction. But that location is stored by the application in order to provide you the service, but also it's reported to a central, let's say, company that stores these locations in order to use it for marketing purposes, for example. There are many applications that use the location, and they ask you to report your location. The company that we're working is one of them that uses the location data in an aggregate and a private way to analyze the movements of people and do marketing or other purposes with that location data. The good thing is that this is GPS. It's actually not GPS. The technology behind is called assisted GPS, which is not the commercial GPS technology. The typical resolution is about 5 meters to 20 meters. And more or less, because these applications are running in the background, you have the location every 10 or 25 minutes. And the last technology is, during the COVID times, probably you have heard about that. The last technology has been Bluetooth. Bluetooth has been used also for location purposes, not only for connecting to your headphones, but also for location purposes. And the reason is because you need Bluetooth has a very short range. It's from 1 minute to 1 meter to 10 meters. And the reason of using Bluetooth is because we wanted to extract contacts. We wanted to extract when two persons are one facing each other and actually talking. In that sense, you can have a contact, and in that sense, you can have a transmission, for example, of the call. So these three technologies you can see comes from the very same device. They have different frequencies, and they have actually different spatial resolutions. So depending on the application that you have in mind, you can actually use one or the other. Also, they have different spatial resolution, but also they have different scales. For example, the Bluetooth typically is not reported always, while the GPS is only reported every 10 minutes and 20 minutes. So there have been many applications of this, and what I'm trying to convince today is that this is a very powerful technology to do computational social science. And the reason is because this technology can inform us about three different things of human behavior. The first one is mobility, how you move around the city. That encodes a lot of information about how people behave, who they are, who is these people, and also what is the kind of inequalities in how you move around the city. The second thing that is important to understand in computational science is that it allows us to encode encounters and even interactions within the city. So how people encounter themselves and how people interact between themselves. And the last one, obviously, is that they allow us to study propagation of things that are happening on top of this movement, like, for example, the COVID. Okay, and this is very important, especially in cities. I probably don't have to convince you that since you are living in a very big city like Hong Kong, is that by 2050, there are projections that 75% of the population is going to be living in a city. The cities are going to be the places in which most of our interactions, most of the innovation, most of the creativity, most of the industries are going to be taking place in the next 100 years. So cities are very important, but at the same time, during the last years, a lot of people have started to look at the actual problems that cities are developing, which are new. Some of them are new, some of them are pretty old, but most of them are entangled. So there is not a unique, there's not a problem in this list which is disentangled from the other ones. I'm bringing you here one of the many reports that you can see on the web about the future of cities. This actually was done by the European Commission, and found that there are like 8, 9 problems. It depends on the report, how you read it, 8 or 9 problems in the cities which are actually entangled one with each other. And they are, for example, environmental impact, the aging, the housing, the new forms of government, obviously mobility, the new forms of mobility, the social segregation, the labor markets, and also the epidemics. In the last couple of years, we have been working in social segregation, labor markets, and epidemics. And today I'm just going to talk only about social segregation and epidemics. One of the key ideas that I want to convey in this talk is that most of these problems, when people talk about most of these problems in cities, most of people talk about places. They talk about parks, they talk about libraries, they talk about a school, they talk about where you have to put the bus stop, where to have to put the pedestrian cross, etc. But I'm going to try to convince you that these problems are actually the combination of two things: places and behavior, and also interactions. So most of the things that happen in the city is true. Most of the things that happen in cities has to do with infrastructure, I mean, how the shape of the cities. But I'm going to show you that they also have to do, and sometimes much more, with the behavior of people which are living there. And let me just focus on the 2 projects that I'm going to talk today. One is segregation and the other one is epidemics. And we are going to try to study those problems of segregation, once again, by putting together the shape of the city, but also the behavior of people. You probably know that, and this is actually an online segregation, you probably know that we have well, there has always been segregation in our societies, but today we are suffering probably the consequences of this massive scale of segregation and polarization in our society. This is, for example, the polarization that we see in social media, when each of the dots there is a Twitter account. they're basically Republicans and Democrats, and how they talk to each other, and how they follow each other. And you can see that in most of the conversations that you monitor online, and probably the same will happen in other geographies, most of the conversation is polarized. So basically people that have the same opinion are basically talking to themselves, and there are not many people actually crossing the, let's say, the bridge and talking to the people in the other. The manifestation of this problem of polarization in the city, in the geography of city, is what we call social segregation. Okay, social segregation is actually a problem which is getting worse and worse. For example, during the last 20 years, social segregation, especially the income social segregation in cities, has been increasing in most of the developed countries. For example, in the United States, it's been increasing almost like 50%. By some metrics, we are in a situation in which the social segregation now in the cities and the inequality in the cities is as the inequality that we have during the last depression. I mean, in the 1920s. So we are 100 years after that depression, we are coming back to the levels of inequality and segregation that we have in that area. When people talk about social segregation and income segregation, obviously there's moral and ethical reasons why economic segregation is bad, but I'm just going to bring here the economic impact of that. The fact that we live apart is not only a problem for the people that live in the, let's say, the less affluent areas. It's a problem for all of us. It's even the problem for the companies, even for the rich people. And the reason is because the places which are more segregated, they have more crime. They have a slower economic growth, and they actually become less innovative in the future. Okay, the fact that we live apart from each other creates more crime, creates more difficulties, more economic barriers, more let's say financial barriers for economic growth. But obviously, for the people that are living in those areas, it's actually even worse. In the United States, just living in very different zip codes can result into 10 to 15 years of life expectancy. So people that are living in highly segregated areas live up to 10 to 15 years less. And they have also fewer years of secondary education. And this is a problem for everybody. It's not a problem only for those people. So we have to solve this problem. And obviously, this is a very complicated problem. But I'm going to try to our project is about trying to see where are the barriers that happen in the city and where are the barriers that are encoding into the behavior that promotes that segregation or that alleviate the problem of segregation in our cities. What I was saying is that when you talk about segregation in cities, this is the picture that most people have in mind. I don't know if you noticed, there is this is a picture of Mexico City, in which you see that the right-hand side looks like an affluent area, in which you see all these houses that look nice, while on the left-hand side you see this slum-like neighborhood, which seems to be poor. Okay, and this is basically how people picture segregation in the cities. Like we are living next to each other, but people on the right-hand side basically don't go to the place on the left-hand side. Okay. But during the last 2 years, as I was saying, I've been collaborating with companies that have this location data. And what I'm going to talk today is about the mobility of millions of people, millions of users in these 11 cities in the United States. And by city, I mean the metropolitan area. So you can see here, for example, that the metropolitan area of New York is huge. The metropolitan area of Boston includes areas in New Hampshire. So this is not just the city, it's also the metropolitan area. What we have is basically the mobility of people, how people move around, but also we have the places they go. Like, for example, when they stop for a while in a place, we detect that movement and we say that this person has been in this restaurant. Okay, so that's what we do. So we have basically the trajectories of people moving around in the city, but also what is the type of things that they do. Going to a restaurant, going to a bookstore, going to a library, etc. And one of the things that we found is actually that 75% of the people that you encounter every day in an American city lives more than 15 kilometers away from you. This is 75% of the people. So think about your department, think about the place where you work. Most of the people, I don't know the situation, probably in China is different, but in the US, most of the people that work with you, they come from really far away from where you live. So if there is segregation in our cities, it must be, if there is segregation in our cities, it must be happening far away from where we live. Okay, the 75% of the people which lives far away from you, if we are experiencing segregation, they must come from very different places. So that's what we want to do. We want to understand if there is segregation, where this is happening, where is this segregation happening, and obviously the question is why this is happening. Okay, so this is the paper that we have just published that tries to answer that question by understanding the places in which we don't get together, and also the reason why we don't get together. Okay, so let me talk a little bit about the data. So you probably are interested about the data that we are using. The data comes from the mob, as I was saying, from location-based technologies. It's a company which is called CUHK that allow us to analyze this data to detect the following. So basically what we have is trajectories of a person. We know when the person enters a place, for example, this pizza place, and by looking at the different people that enter that pizza place, we can reconstruct what we call the distribution of the income of the people that visit this restaurant. In this case, for example, the income could be from low income to high income. In this case, you have the restaurant, which is the pie, and this place is mostly visited by high income people. And low income people are visiting, low and low middle income people are visiting this place in a small amount of time. So if you go randomly to this place, this is the kind of people that you will see there, okay? So we did this for 1.1 million places in the United States, and we characterize each place by this distribution of the income of people that are visited. So basically what we wanted to do is the Gini coefficient for a single place. That's the reason. We don't call it Gini coefficient because it's not the Gini coefficient, but it's very similar. And what we did was to compute what we call the inequality of the place. And the inequality is basically how different is the distribution of the different income groups, or how the time that the different income groups spend in that place with respect to, let's say, the flat distribution. You have to know that the groups that we have in our database are split into 4 quantiles. Okay, so each group has 25% of the population. So a place which is visited homogeneously by those 4 quantiles will have a distribution which is flat, and then the inequality will be very small. Basically, this is the difference between the data and 1/4, the 25. But this place that you have here, the one on the right-hand side, this is a very unequal place because the difference of the distribution to the flat, let's say 25% distribution, is very high. So this is very unequal place, okay? Very simple. I mean, we have tried many other definitions of inequality. We have tried other definitions of number of quantiles, etc. Everything is in the paper. The results that I'm going to present do not depend critically on this definition. So bear with me, this is not critical. The definition is not critical. The actual measure of inequality by the deviation of how different people visit that place is what is critical here. And we put together all this data, and you can actually navigate this data. We created what we call the Atlas of Inequality. You can actually find it online. It's at inequality.media.mit.edu. And this is basically Atlas of Inequality. Each point that you see here is what we call a point of interest. It's a restaurant, it's a bookstore, it's a park, it's a bus stop, it's a shop, etc. And the color indicate this quantity, which we call inequality, which is the one that I was showing before. So the reddish point here, for example, that you see here in the Bronx, are places which are very unequal in the sense that they are just visited by one income group. And the places that you see downtown Manhattan, by the way, this is New York, sorry, and this is Central Park. And the places that you see here downtown Manhattan are very bluish, because basically if you go to those places, you find people from all over all the income groups in the city. You can see things here which are expected. Like, for example, downtown Manhattan, you see people from most of the incomes. But if you go to the Bronx, or you go to Queens, or you go to Newark, you start seeing a lot of reddish points because those places are just visited by the locals. Okay, and you have 11 cities in the United States there. You can navigate and you can see all the places. There are two things that we found in this map. The first one is that the spatial resolution, even though you see a lot of bluish together and a lot of reddish together, if you look carefully, you can see bluish point very close to reddish points all over the place. You can see very unequal places close to very equal places. This is an example. This is actually the places where I used to go for where I go for lunch, close to the Media Lab. And there are two places. One is Clover Food Lab, and the other one is Chipotle. And you can see that they have very different distribution of the people that visit them. One is mostly rich people, and the one is basically people from all over the income groups. And this place, Chipotle, is much less segregated than the Clover Food Lab. The distance between these two places is 50 meters. Okay, it's 50 meters. And the sandwich, you can get a sandwich here for $15. So it's not the price, which is given here. For those of you that are working on spatial analysis, another way to encode this spatial variability is what we call the spatial correlogram, in which we did was basically to compute the correlation of the inequality as a function of the distance. And you can see that the correlation, even at 50 meters, is only 0.4, okay? Which means that close to a place which is highly segregated, you have another one which is low segregated, okay? Even across the street, you can find a place which is not segregated. So that means this is actually a striking result showing that segregation is happening even at the site, at places which are just 50 meters apart. Okay? And just by, for example, deciding to go today for a particular restaurant, you are gonna end up just seeing people of a particular income group that if you cross the street and go to another restaurant. The other thing that we found, which is you couldn't see in this map, is that if you analyze the inequality of the places by the category, by the type of place, you can start immediately seeing things which are expected. The first thing is that this is a plot which is very complicated. Each of the points here is the aggregate value of the segregation for all the schools, for example, in the United States. This is the point here. Or for all the warehouses in the United States, or for all the science museums, okay? And this is the vertical axis. And the horizontal axis is the distance that people have to travel to get there. And things, you see things here which are expected. For example, you have to travel a lot to get to a gate at the airport, or you have to travel a lot to get to a science museum, or to a platform, or to a exhibit, a stadium, a theme park. But on the contrary, you have to travel less to go to a supermarket, or to go to the church, or to high school, okay? You see that there's a lot of correlation between how far things are and how segregated they are. These are basically the neighborhood places, the local places, and this is basically like the facilities which are citywide, like for example, the airport. And you can see that the farther you have to travel to them, the more unique they are, the less segregated they are. This is a couple of things here is that you see that elementary school and religious places, also check cashing and pawn shops, are the most segregated places in the United States. And the less segregated place in the United States always is science museum. No museums, science museums. Okay? It is very interesting to find that science museum is those places in the cities in the United States which are frequented by all income groups. Although there is a correlation here between the category, let's say the type of place, and the accessibility and the segregation accessibility, you can see also that the working places, for example, not everything is explained by the accessibility. You can see, for example, here in the working places, that everybody in the United States travels around 15 to 18 kilometers every day to go to the working places. But depending on the type of working place you go to, you can be much more or less segregated. For example, you go to offices, you are as segregated, or you will be as segregated as the average place segregation. But if you go work in a factory, in a warehouse, you are still segregated. You travel 15 kilometers and still you are segregated. Okay. Not only that, I mean, like for example, that the type of food that you eat is in the United States also determines the segregation. I can tell you, for example, this is the restaurant. This is the same plot, but you can see here is this average segregation as a function of the distance. for the places for the restaurants of the different categories. You can see, for example, that the most segregated places are Spanish, Caribbean, Latin American, fast food places in general are highly segregated, while the less segregated restaurants are Tex-Mex. For those of you that like Asian food, the good news is that most Asian food is actually very mixed. It's actually less segregated, except in Chinese, which probably in the United States is probably different. I mean, it's more, there's a lot of fast food which is associated also to Chinese, so we couldn't disentangle this. So even if you like different, so even for example, if you like different food, you can be segregated different. So that tells us that there is something else about so the fact that the segregation is happening at the street level, and also the fact that the type of place you go result in be exposed to different people, that tells us that most of the segregation, if it's happening, is probably according to how we move around the mobility patterns that we have. Well, I'm not going to comment that. So this is the why part. So we wanted to understand why people are segregated. So what we did was the following, is that we actually compute the amount of time that each person spends in different places. And by looking at the people that visit those places, we can reconstruct the distribution of the people, the income that a single person sees every day in the city. So this could be, for example, me. By going to Aceituna Cafe, Cloverfield Lab, and MIT, let's say Media Lab, which is this one, I see people mostly of high income and medium-high income. Okay, so I can compute also my inequality, pretty much like we did for the places, and I can see that inequality here for myself is that I'm experiencing a 40% inequality because most of the people that I see every day come from a particular, let's say, income groups. So this is what we do. So we did this for 1 million people in our database. And we wanted to understand in these 1 million people, the reasons behind why people are have a large inequality. They experience only people from one income group, and why some other people experience a much more even distribution of income groups in their lives. And to do that, and you know, I mean, you're coming from a computational social science group, there has been a lot of literature about how we move around the city. One of the most studied things in computational social science is probably the mobility of humans in cities. And one of, for example, of the models that is very successful in explaining how we move around the city is what is called the exploration and preferential return model. This is a very simple model that states the following, is that every time a person decides to move around the city to a new place, she decides to do two things. Either she goes to a new place, okay, and that happens with probability rho divided by sigma to gamma, S to gamma. Capital S is basically the number of places you have gone to, meaning that if you have gone to a lot of places, the chances to go to a new place is actually very small. Okay. And with probability 1 minus PDO, you basically come back to a place you have already visited. But that doesn't happen randomly. You actually come back to places that you have visited previously proportionally to the time that you spend there. Okay. So that means that at the end of the day, you are doing this recurrent movement in which you come back to the places that you have already visited. But think about it. I mean, you spend a lot of time at home, you spend a lot of time at work, you spend a lot of time in your favorite restaurant. And the reason is because you come back to them with more probability, as much proportional to the number of times that you have been there. This is a very famous model. This is not actually our model. It was proposed almost 7 to 8 years ago. And it works. I mean, actually, it reproduces very well the distribution of time that people spend in different places. Okay, but nothing tells us, this model doesn't tell us anything about segregation. This doesn't tell us about why people decide to go to places in which the income of people visiting this place is different. So we extended this model by combining this model with the Schelling model. The Schelling model, which is a very famous model in economics, states that people have preferences to be surrounded by different people. And in general, people are more comfortable being surrounded by people which are equal to them. Okay, so obviously there's a parameter there, which is what we call the social exploration model, the social exploration parameter, the sigma s, which measures how comfortable you are, how willing you are to cross, let's say, this barrier and be surrounded by people, which is very different for us. So every time a person decides to go to a new place, like you see here, we have this social parameter, this sigma, this social exploration, that tell us that with probability 1 minus social exploration, you go to places which is very similar to your income. You see, you go to places in which you are surrounded by people of your income. And with probability sigma s, you explore. You go to places in which you are surrounded by people which are not similar to you. Okay. Of course, if sigma s is equal to 0, if people are not willing to explore, all the places that you visit are totally segregated, and the income, sorry, the segregation of people will be 100%. Okay. So this is what we did, and we encoded the movements of people. We run this model, we fit the parameters for everybody, and for everybody, we detected what we call the social exploration, the sigma s, and also what we call this the place exploration, which is basically a combination of this parameter rho. Okay, tell us how willing you are to explore new places. Okay, so it's a parameter that goes from 0 to 1, and 0 means that you don't explore places; you just basically come to the ones that you have visited. And the sigma explore and the place exploration equal to 1 means that every time you go to a place, it's a new place. So this is what we found. This is the distribution of the two parameters. The first one is the social exploration. How willing is people to visit places in which they are surrounded by different people? And you can see that the people are actually moving a lot, and they're actually choosing places which is in which they are surrounded by people different to them. Okay, the average is around 0.8, so 80% of the times people are going to places in which you are not in the majority. Let's say you are not surrounded by the same people as you. And for the place exploration, we see that the parameter is around 0.4, meaning that 40% of the times when you choose to go to a restaurant, for example, you choose a new one. Okay, so these are the two parameters that we see in the database. The question is, what is the origin of this? How people have different sigma p and different sigma s, and that controls actually the segregation that people experience. But what determines sigma p and sigma s for a given person? So this is what we did. What we did is basically we took a person that is described by these three parameters: the sigma s, the social exploration, the place exploration, but also the total segregation of the person. And we wanted to understand this in a very simple way, using a very simple regression model, in how these parameters, sigma s, sigma p, and s, depend on residential demographics, like, for example, race, poverty, income, the level of education, etc. How far you go, you can think of, like, for example, if there's a person that doesn't have a car, the chances of meeting people different are lower than a person that has a car. So this is actually encoded into the distance travel, the radius of direction, but also on the type of places visited. As I was telling you, if you visit a Chinese restaurant, on average, the people that you meet is different from if you go to a Spanish restaurant. Okay, so the type of places that you visit is also going to be important to understand what's happening. And what we found is actually very striking is that sigma p, the type of places that you visit, so the number of places that you visit, or the willingness to explore new places, is almost encoded into the places you visit. If you tell me that you have gone to the theater last year, I can tell you that you are a place explorer. You like to go to restaurants. You like to move around. You like to discover new things. Okay, this is obviously not one-to-one, but there's a huge probability that if you have gone, for example, to a theater, that you are a place explorer. So in the model, basically, it means that most of the variability in sigma p is explained by the type of places visited, by the lifestyle of people. Okay. But when we talk about the other parameter, the sigma s, I mean, the willingness that if you go to a new place, that you choose a place which is, I don't know, only for rich people, only for poor people, only for middle income people. This does not depend on the type of places you go to. It depends on your residential demographics. It depends on your income, on your education level, on the transportation, if you have a car, in the family composition. And these are basically the two completely orthogonal dimensions of segregation. One is how you explore the city, whether you like to go to a museum or not, or you like to restaurants or not. And the other one is that given that you like restaurants, the type of places that you visit, the type of restaurants you go to. As a result, you put together these two, because segregation is let's say the combination of these two parameters. Half of the segregation, half the variability of segregation can be explained by these variables, by these behavioral variables, and half can be explained by these residential demographics. So the way we experience segregation in the cities is not explained by where we live. It's explained by where we live plus what we do. Okay, and what we do is actually much more important than what we live. And I'm going to just be briefly here. This is actually the model for the individual segregation. And basically, this is the result. This is the regression table. What we see is that 55% of the variability explained in the individual segregation is encoded into what we call behavioral variables, how you move around and the choices. And half is explained, or less than half is explained in residential. By the way, for example, income or education only explains 17% of the variability on segregation in our cities. So coming back to the original question that I have, is segregation in our cities something that depends only on the residential patterns? It depends a lot on residential patterns, but a huge fraction of the experience segregation of people every day in the city depends on choices and mobility patterns. Okay, and that's big news. Not only big news, but good news, because maybe we cannot change the income and poverty levels of people so easy, but we can start changing choices and mobility patterns more easily. For example, with new transportation modes, with new transportation facilities, with recommending people to do different things. I mean, there's a lot of recommendation algorithms that can allow you to recommend places which are different or do have different people. For example, we have worked in the past with a music festival in which we were recommending people concerts within the music festival that were more diverse, and people were willing to go there and meet people with different backgrounds. So this important result shows that as the paper is entitled, is that most of the income segregation that we experience in our daily lives in cities is encoded into behavioral variables, into the mobility patterns. By the way, we are extending this idea that the behavior is important to understand cities, and we are starting what we call the mobility-rich census. This is a project that I'm doing with Jang, which is working at PolyU and Sandy Penland, in which basically what we are trying to do is probably you know that the census has all these variables about who you are, like your race, your income, your educational level, etc. We want to extract from the mobility data also what you do, how you move around the city. And we found, for example, that using the mobility data that I showed you, we found that all these places you go to can be embedded into a long-dimensional space. We actually use deep learning here. We use deep learning to embed all these mobility patterns into these 12 dimensions that describe more or less the lifestyle of people. And that 12 dimensions could be computed, for example, by census tract. And we found that actually these behaviors, these latent behaviors can describe problems like health, are related, for example, to transportation, are related to segregation, as I was showing you, etc. And this is actually a project that we are working now, trying to extract from this mobility data what we call the behavioral census that can complement the traditional census in order to understand much better problems like, for example, segregation, health, or food consumption. Okay, so in the last 10 minutes of my talk, if I have only 5 minutes, I'm going to try to convince you that obviously this data is not only useful for explaining the interactions of encounters of people in the city for problems like segregation, but obviously now that you have the encounters of people, the next of the next application, unfortunately, during the last 2 years is epidemics. Because you know when two persons are at the same time in the same place, you can start looking at what is the probability that there's a transmission between these two persons. One of the good things is that of having this amount of data that we have about how people move around the cities is that we have the contact network. We have estimations of how different people get in contact and what is the probability that they transmit the disease from one person to another. The good thing is that traditionally this contact network has been estimated. So you estimate, for example, how many people of 60, 64 years old get in contact with people of, let's say, 5 to 10 years old by estimating how many people live in the house, etc. But we don't have to do this because we have the actual behavioral data that allow us to estimate this contact network almost in real time. And the good thing is that the human behavior is encoded into this contact network. So if today the restaurants are closed, that is immediately translated into the contact network. We don't have to do any assumptions about how people get in contact. Obviously, there's another part of the epidemic, which is the transmissibility. Like, for example, you can be in contact, but you are wearing a mask. And that is a mitigation of the transmissibility part. Most of the mitigation strategies, the hard ones, and China was one of the first places in which that happened, were the hard mitigation strategies, like putting people in quarantine, not allowing people to move from one place to another. That is basically transforming the contact network, making the contact network more sparse, more disconnected, so the people can actually transmit the disease from one side to the other. Okay. The other part, which is the last part, what we are doing right now, with the vaccine, the vaccination is different. These are not pharmaceutical interventions. The last part has been shock mitigation, 6 feet apart, wearing masks, etc., which only modify the transmissibility. You modify people behavior, but modify transmissibility. And as I was saying, we are using this data to actually inform about the contact network. We have a number of projects in this realm. I'm not going to talk about all the projects that we have done, but the mobility data that we have can be, for example, be used for things like this, like how many people are staying home, what is the average distance that people travel. So, for example, this is the New York area. Each of the polygons here is a census tract, and you can see what is the average of people, what is the average distance traveled by people living in that area. This is before the COVID-19. You can see a lot of people in the suburbs traveling 50, 75 kilometers. But then when the lockdown started, people basically stayed home, and everything went dark. And this is one of the uses of the mobility data. But this is not the one. This is actually our work too. But this is not the most interesting use of this data, because as I was telling you, this data can be used to estimate contacts. So by looking at the places that are visited by two people, we can estimate what is the probability that Wij, that these two persons get in contact in a specific place alpha. So I can take what is the probability that me and a colleague I transmit the disease to a colleague by going to MIT, or both together. Okay. So this is what we did. We have been using these contact networks to analyze the problem of how the COVID is transmitted in cities by putting together 3 layers. We have what we call the community layer, which is the CUHK data. This is we measure how people get together in places, but we also put together the school layer and the household layer, which are not included, and they are very, very crucial because, as you can imagine, there are no kids in our database. They're very crucial because the kids are also a vector for the transmissibility, especially of airborne diseases like, for example, flu or the COVID. So this is what we did last year, and was published in Nature Human Behavior. The key idea is that you have, on top of this contact network, on top of the people and the probability that people transmit the disease from one to another, we have a very complex COVID model, which is basically an SIR model in which people live in one of these compartments. And we have many compartments like symptomatic, asymptomatic, infected, hospital, ICUs, etc. And you have all these probabilities here from going from one to another. It's a very complicated model, but it's well, I mean, the people that in our group that are working in epidemiology, they have all the estimations for all the parameters there. I'm not an expert on those models. We just run those models on top of the network the contact network. And the key idea that we did is, obviously you can monitor, and we did two things. The first one is that we did counterfactuals, like what would have happened, for example, if we put in place tracing, contact tracing. So one of the things that we found is that the second wave could have been attained. Actually, the second wave was, more or less of the same size in the United States as the first wave. But if we would have had contact tracing, the ability to put people or to take people outside of the contact network by placing them at home, etc., the second wave would have not happened. We have actually tamed the number of deaths and the number of people going to the hospital by doing contact tracing. So these are the kind of things that you can do when you have data about the real behavior of people. The other thing that we did is basically to study where do these infections happen, and who and how much those informations are happening. And what we found is actually that in the depending on the place, depending on the time, and depending even in the city, the places that where most of the infections were happening and were actually changing in time. You can see, for example, here New York, and this is basically the colors in this map, which is basically, this is the contribution to super spreading events, and this is the fraction of the infections. So more bluish means more infections, more reddish means that those infections are created by less number of people. You can see that Seattle and New York actually have a very different trajectories, for example, for arts, museums, and groceries, that very different trajectories in those categories. For example, groceries were at some point in New York were creating a lot of super spreading events, and arts and museums were creating a lot of super spreading events. While in Seattle, arts and museums never created super spreading events. And the reason is because the behavior of people in New York and Seattle is totally different. So when we talk about closing the restaurants because they are bad, you have to actually think that restaurants are bad or not so bad for the, let's say, for the epidemic purposes. And that, for epidemic purposes, that depends on the behavior of the people in the city. So for example, Seattle is a very suburban area, and there's a lot of people actually living in the suburbs, while New York is a very high dense area, and there's a lot of people living in these very high dense areas in the city. So the result of this paper is that by monitoring, by using the real-time behavior of people, we can build these contact networks in real time, and we can assess in real time the risk of getting infected in different places, but also the amount of places, the amount of people which are getting infected, and the amount of super spreading events that are happening in the city. And they are not equal. They depend a lot on the moment, on the seats, on the lockdown, etc., in the different cities, because behavior depends on the cities. Just to finalize, we published another paper this year in which we studied not only the direct impact of using mobility data, not only the direct impact of the COVID on the number of cases and unfortunately on the number of deaths of people, but also on the second, let's say, on the second physical impact of COVID, which is that since everybody was staying home, people actually walked less. And the physical activity of people decreased a lot. You can see here, this is the pre-COVID or the pre-lockdown and mobility. This is each point here is basically a walking activity. You can see here before the COVID and during the lockdown. And you can see that most of the walk behavior within the city, this is the Boston area, disappeared because of the lockdown. And of course, not everybody was equally affected by these lockdowns. What we found, once again, is that low-income people actually decreased their physical activity much more than rich people. Rich people, affluent people, substituted what we call the utilitarian walk. I mean, the fact that you have to walk around your workplace or you have to walk to shop, etc. They substituted by walking around their houses. While poor people could not do that, and because of that, low-income people actually were doubly affected by the pandemic. Not only they were the ones that having more cases of COVID, but also the physical activity levels decreased much more than the rich people. So that's what we call the double pandemic. Okay, so let me finalize here the conclusions. I guess I don't have to convince to the audience here, since you come from a computational social science, that we, during the last years, we have access to these massive data sets, and the way that we can create more resilient societies, or one way to actually understand how we can create more resilient societies is to use more data, to have more data, more high resolution data about how people contact, how people interact, how people encounter, to actually model better the evolution of cities. I always like to bring this example of two materials, the graphite and the diamond. They're made of the same material. They are made of the same material. The only thing which is different in both materials is the network here. Is how the nodes are connected. And without understanding how the nodes are connected, you cannot understand how you can go from one to the other. Or you cannot understand what are the properties of one to the other. So if we want to create more resilient societies, we need to understand in high resolution what is the connectivity of people, how they encounter, how they interact, and how they move around the city. And with that, I will just want to mention that we have what we call a MIT Mobility Initiative, and we are doing many other things that have to do with mobility data. We have, for example, a project in which we are analyzing what is the impact, what is the privacy side of the use of this data, how we can actually build tools on top of this data which are privacy preserving, they're fair, they're equitable, etc. We're also working on food environments. We are also working on the food accessibility, when people are making the decision to have food, how the mobile food environment is affecting them. We are working on equitable transportation, how we can actually make transportation more equitable. The mobility use rich census is a project that I'm doing with Gianni. And also we are working on the online versus offline segregation. Most of the things that I talked today are physical, they're happening in a place, but there is also the connection with what is happening online. And there is probably a dual segregation, which is all happening not only in the physical space, but also in the online space. And we have a project in which we plan to investigate what is the connection between this offline versus online segregation. And with that, I would like to thank again for the invitation, and I'm open to comments or questions and criticism. Thank you very much.
Yeah, thank you very much. Very stimulating and insightful talks covering several studies, including social segregation, COVID-19, etc. Yeah, okay, now the floor is open for questions.
I have a question. I think I put in the chat. I've already put in the chat. So basically, I think when you mentioned that segregation, social segregation and or residential segregation, they're bad for cities because it introduced more crimes and less economic development. I'm wondering, like, while you calculating different index, do you find there's any like threshold value that's like ideal? Like it may reduce crime, but also increasing interaction. Because I know, like from crime literature, sometimes unstable community, it's also very mixed. But it's a lot of crimes in this kind of community.
Yeah, that's a very good question. Thank you, Ivan, for your question. It's a very good question. I mean, actually, the COVID-19 tell us that segregation is not bad sometimes. I mean, probably the situation in which there has been more segregation in our cities, in the history of cities, was during the lockdowns, because people were staying home and you were not allowed to actually leave your neighborhood. So we were as much segregated as we can be, okay? So being segregated is not bad by default. The problem is that if the barriers for not being segregated are surmountable, I mean, that you can actually, the fact that there's a choice to be segregated or not. I mean, in most of the communities, the segregation is something which is not optional, it's enforced. So, so in that sense, I think that's the problem with segregation. It's not about the level of segregation, it's about how much a community can decide to be segregated or not in the everyday activities. But you're right that for example, for some kind of type of crimes, it's very well known that you need eyes on the street, right? You need people on the street to prevent crime. So if you need people on the street, you need probably neighbors. And you probably need more people live on the street which are from the same area that you live. And that is actually, let's say, segregated. In social networks, there is this thing about the role that strong ties and weak ties play, and opportunities, for example, job opportunities, economic opportunities, they come from weak ties, which is probably that you are less segregated in the sense that you get away from your community. But strong ties are also very important for trust, for community building. So I'm not saying that segregation is bad. I mean, for some specific purposes, having a community which works together, and for example, think about that you have a community center in your community that works towards fixing things which are not working in your community. That is good. It's good you have a segregated place in your area, because this is basically the people that are living in the area trying to solve problems in the area.
Thank you.
Okay, any other questions? Actually, I have a quick question. How did you get the income data for people?
Yeah, so the income data, we don't have any data about the users behind the data. So what we do is we estimate the home location, the place where they spend most of the night. And then we go to the census and ask what is the typical income of the people living in that area. Fortunately, for us, unfortunately for the research, the cities are very segregated. So most of the people that are living in an area have more or less the same income. So this is why we are confident that, and we have a number of tests in the paper about this. We are confident that income is very well. I mean, the estimation of income is very good. It's very, it works very well.
Thank you. Any other questions?
I do have another question.
Yeah, please.
So basically, I think your research depends a lot on the availability of the mobility data from cell phone company who compile all this for different researchers. I think in certain area, probably for example in Hong Kong, I think the most comprehensive mobility data is due from research, like from travel diary. Do you see is there anything like from the mobility data that you get that cannot be covered, that might be even reviewed more from the travel diary, this kind of more traditional data?
Yeah, I mean, the mobility data, the good thing of the mobility data is the scale, that we have millions of people, millions of actions, etc. But the bad thing about the mobility data is you don't have a lot of semantics. You don't have a lot of information about what they're doing there. What is the type of things, if they go with people, for example, or if they decide to do this. I mean, this is the kind of things that you can get from the diaries. Like you can actually ask people questions about, do you go to this place to socialize, or just to have a coffee, or both, or you go with friends, or you go always to this place because of what reason. So that's the kind of thing that you can do with the diaries and with surveys. And I think for me, and this is a general thing for computational social science, I think just relying on the big data set is not a good idea. Because typically this big data has not a lot of semantics. So we have to complement this with surveys. We have to complement this with small data. And that's the only way, and also to work with communities on this data. So that's the way to go, to complement this thing. So I don't see that one substitutes the other. I see them more than one complements the other.
Thank you.
Any more questions? So when you look at the social segregation problem, you mainly study the segregation in different places, right? So I was wondering whether, I mean, the mobility pattern can determine the segregation pattern directly. in terms of contact network, etc.
Yeah, so yeah, go ahead.
I mean, yeah, does it make sense? I mean, it's a question.
Yeah, it makes sense. Like as I was showing you, the fact that we have all these different places that have different segregation, even in the same area, tells me that if you and I go to the same area and we choose different places, we can be very differently segregated. Just like going to the same area, basically being in the same place, but making different choices or making different actions, or taking different actions to the place that we go, we can be different segregation. So this is why in the paper, I mean, the title of the paper is that basically the exposure and the segregation, the way we've experienced segregation in our cities is encoded into the mobility variable, into the mobility patterns. It depends on how you visit the places, which places you visit, what time of the day, or which is the place of the city, but even just the type of places that you like. If you like a coffee shop or you like, for example, a tea shop.
Any other questions from the audience? Please.
Hello, may I ask you a question?
Sure.
Like in the regression model related to segregation, you consider 3 components like residential, demographic, geographical mobility, and places visited. So my question is how you have incorporated like different places into one variable like P, or how you have calculated the residential demographics into one variable like R. So may I know how you have incorporated in the model?
Yeah, sorry. I mean, I was using a notation which is probably not very explanatory. Sorry. I mean, when I was, this is the model you're referring. This brackets means that there's a huge number of variables here within. So basically, the models contain. This is a 1.1 million observations. So this is 1.1 million users, and the number of variables here are the order of hundreds. Okay, so for example, in this one in RI, you have the fraction of African Americans living in the area, the income of the area where this person lives. For the mobility, you have the radius of gyration. You have also the distance travel. For the places, this is basically a 250 something dimensional vector that includes the amount of time that you're spending in different categories of the places, going from restaurants to shops to educational levels, etc. So the notation that I'm using is brackets, but within those brackets, we have a lot of variables.
Thank you very much.
Yeah, and you might think that this is a problem because we are using the order of hundreds of variables to describe the SI, but we have 1.1 million observations. So we are not overfitting here clearly. And I mean, this is not, I mean, in the paper you can find, we also did lasso some other techniques to detect which are the more relevant variables in these regressions. The exercise here, we didn't want to have fancy models here. It's just, we did regression models because we wanted to have more interpretability.
Any questions? Any questions?
Also regarding the model you show on A7. So basically, I think there was a belief that people from low-income community might have to subject to more routine life. That, like for example, they don't have time for a lot of leisure. They have to go work because they're paid by hours, and then they go to pick up keys. So, but in your model, it seems like the income level only explain 10% of the segregation, which kind of gives like a hope that people even from low-income area can still have a lot of exposure to social life. Do you think this is something can be get from your model, or if there's anything I like it shouldn't be interpreted in this way?
Yeah, I mean, you're absolutely right. Like I mean, the fact that the income is only, let's say, 10% correlated with the final experience segregation, tell us that even people that are living in poor areas can be integrated or have a more diverse experience every day. And the reason is because of the job, because of the place they work, or how they shop around, or the activities that they have. So it's interesting to see, for example, that this is probably something which is very unique to the American, let's say, cities, because in the United States, mobility, even though mobility is partially constrained by income, is not very constrained by income. So here in the US, even low-income people have a car, and they can move around, they can shop wherever they want, they can move around very easily. Of course, there are limitations to that, and there are many well-established limitations to that, but it's not like, for example, in other geographies. For example, we are working on translating this into Mexico, and in Mexico, for example, there's low-income people have really difficulties to move around. They don't have time to move around because they don't have a car. They have to take public transportation. Public transportation takes a lot of time, so a lot of people actually stay home. So in that sense, probably if the result that we saw in the United States, and especially in large urban areas, cannot be translated to other geographies and other countries. So that's something that we have to keep in mind.
Cool.
Okay, we got a question from the chat window.
Yeah, which is not including. Yeah, you're right. So one of the things that there's a question. I'm going to repeat the question. So there is a question that in our model we obviously we decide which variables to put as regressors, as inputs in the model. For the census, we took a number of residential demographics, and the question is, there can be more layers of information that affect the results. For example, physical environment, like how accessible, for example, is a place, etc. So we didn't include accessibility. This is actually something that we are doing right now. Like there could be the thing that, as I was saying, that some people, just because they live in a special area, they have the more diverse places far away, in the sense that they are less accessible. So that could condition the experience segregation. So we didn't do that explicitly in the paper, but we accounted for, we have in the paper, in the models, we accounted for a number of fixed factors that are proxies for that physical environment. Like, for example, we have a fixed factor by Puma area, which means that this is basically the neighborhood. Okay, so this is done by census block group, but this is more like the neighborhood. So in the paper, we accounted for, obviously, within a city, there are very different areas. They have different accessibilities, different public transportation, for example. And in the model, we believe that those fixed factors account for those differences in the accessibility. Also, the physical environment could be important. Like it's not the same thing, like, for example, going to a shop or a library in which you have a lot of open spaces, and the library is huge. So there are more chances for different groups, for different people to go there. So that also affects the accessibility. And yeah, I would like to mention that Yuan, the person that was asking before, is working with me specifically on the physical environment of the streets, and how the physical environment of the streets can explain partially the experience segregation of the people living there. So we see that places that look safer in general have different income segregation than the places that look less safe. Okay, and I don't know, maybe Yuan, you can talk a little bit more about the variables. We are working on that direction. Obviously, there are many things that can affect, and I don't know if you noticed, but in the models that it was not our intention. We didn't want to do a predictive exercise. The models only account for around 60% of the variability in the data, meaning that there are more things that affect the experience segregation, which we didn't account for. Thank you, Ria.
Any more questions?
One more question.
Please.
In the epidemic model, I mean, I know whether you have incorporated the segregation model, and if yes, then how you have incorporated the segregation model in the epidemic model?
Yeah, in the epidemic model, we didn't. So the model that we have for the segregation is very, it's like it's a way to encode the individual segregation of an individual, sorry, for a person. So we didn't use that for the epidemic, because in the epidemic model, what we like to understand is more the, let's say, the behavior of the whole, let's say, population in the city, and how the number of cases, the number of deaths, the number of hospitalized people involved in them. So we didn't actually use the social exploration and professional return model in the epidemics. Okay, but I can tell you that one of the things that we are doing right now is to try to see how segregation, the experience segregation, evolved during the COVID-19, and especially since most of us are, a large fraction of us are staying home much more than before. The bad news is that we are much more segregated than we were before the pandemic. So the chances of meeting people from different incomes have been reduced dramatically in the urban areas in the United States. Okay, so one of the outcomes of the lockdowns is that we have to be segregated, because that's the only way to stop the disease. But that translated into a change of behavior. We have changed our behaviors. We don't go to concerts anymore. If we go, we minimize the number of concerts that we go. We don't go to a lot of restaurants, maybe because most of them closed down, or because we don't want to be exposed with the new Delta variants or the new variants. Maybe we are afraid. So that actually translated into less opportunities for people of different incomes to get together. And we actually, unfortunately, are much more segregated than before the pandemic.
So any more questions? So if no questions, we can stop here. Yeah, thank you very much, Esteban. It's a super interesting talk. I enjoyed it very much. A lot of innovative ideas, but I mean, it includes many aspects. Probably takes time for us to digest. Yeah, thank you very much.
Thank you very much for having me. Thank you very much for having me.
Good night.
Good night.
Yeah, good night.
Have a good day, everybody. Thank you.
Thank you. Also, thanks all the audience for your participation.
Thank you, everybody. Yeah.